Welcome to Podcast on Dialogues in Science and Technology, where lab breakthroughs meet everyday life. Today, we dive into entomology, the scientific study of insects, a discipline of profound and growing importance, functioning as a critical nexus for addressing some of the world's most pressing challenges in food security, human health, and technological innovation. Grab your curiosity. Let's make science and technology conversational.
Okay, let's unpack this. Today, we're diving deep into entomology, the scientific study of insects. And our mission really is to explore how these tiny creatures are this powerful dual-sided force. You know, a source of huge challenges, pests, diseases, but also an irreplaceable source of value. Think food security, health, even tech innovation.
Exactly. And what's really fascinating, I think, is seeing how entomology itself has changed over time. I mean, you go from something really ancient and practical, like silkworm farming in China way back 4700 BC, and now it's this modern, really interdisciplinary science. Its applications, well, they touch almost everything.
Yeah, it's kind of startling when you think about it. Even with all our modern farming, insects are still like our main competitors for food, right? We hear about crop loss, but the numbers are just... Wow. Insect pests causing up to 40% of global crop loss every year. 40%. It's huge. And the invasive ones, they cost the global economy something like an estimated $70 billion annually. $70 billion. That's just, that's a massive hit to food security. And, you know, it affects prices for all of us.
It does. But, and this is the crucial flip side, for every insect causing problems, there are countless others that are, well, essential. There are partners. Think about pollinators. Their work supports, between $235 and $577 billion in global food production each year?
That's an incredible range.
It is. And get this, 35% of the world's food crops depend directly on animal pollinators. Even something like chocolate relies entirely on this tiny little midge for pollination, the whole $100 billion plus industry.
Wow. Okay, so that underlines our dependence. Beyond pollination, though, what about insects as natural pest control? You hear about ladybugs, that kind of thing. How are we actually using that now, like with integrated pest management, IPM?
Right. Well, lots of insects are predators of the pests we don't want. Take that lady beetle example. A single one can eat up to 5,000 aphids in its lifetime. 5,000. So these beneficial insects are really key for IPM strategies. The whole idea is to cut down on chemical pesticides by encouraging these natural enemies. And to make it smarter, the Entomological Society of America, the ESA, they're pushing for investment in new tech. Things like drones, digital sensors.
To track pests better.
Exactly, to create these open source systems so we can manage pests more effectively, more precisely.
And we shouldn't forget their kind of unsung role in just breaking things down, right? Decomposition, nutrient cycling.
Oh, absolutely vital. Dung beetles, termites, they're constantly working, keeping soils fertile, keeping ecosystems healthy. Really foundational work.
Okay, let's pivot a bit. Human health. Insects are, unfortunately, really good disease vectors. We all know about mosquitoes, malaria, dengue, yellow fever. Millions sick, millions of deaths, and a huge economic cost, too, like $12 billion a year just from mosquito-borne diseases.
Devastating numbers. And you've got fleas carrying plague, lice transmitting typhus. The history is grim.
But can they also be part of the solution here?
Yes. And this is where it gets really interesting therapeutically. There's something called maggot debridement therapy, MDT, using specific fly larvae to clean chronic wounds that just won't heal.
Maggots? Really?
Hey, really. And they're effective even against tough bacteria like MRSA, the resistant staph infection. It's quite remarkable.
That is a wild contrast. Okay, what else? Any other medical uses?
Well, researchers are looking at venoms. Bee and wasp venoms have these novel compounds. Melittin from bee venom has actually shown anti-cancer effects in lab studies against breast cancer cells, for instance.
That's incredible potential.
And even their exoskeleton's chitin. It's a strong polymer, and it's being explored for things like drug delivery, tissue engineering, all sorts of biomedical applications.
So beyond the direct health impacts, good and bad, they're also like blueprints for technology. You mentioned forensic entomology.
That's right. It's fascinating, if a bit macabre. Forensic entomologists look at the types and life stages of insects on a body to estimate the time of death, the post-mortem interval, or PMI.
Helping solve crimes.
Exactly. It can sometimes indicate if a body was moved, or even help with toxicology, detecting drugs or poisons the insects ingested.
Wow, okay. And biomimicry, copying nature.
Huge area. Moth eyes, for example, have this amazing structure that prevents reflections. That inspired anti-reflective coatings for solar panels, making them more efficient.
Clever.
Or the morpho butterfly, its wings have this incredible iridescent color, but it's not from pigment, it's structural. That inspired Qualcomm's mirror displays for e-readers.
I think I remember those.
Yeah, and insect movement too. Dragonflies, cockroaches. Their agility has inspired robotics. From tiny flying robots like Harvard's RoboBee to flexible, soft-bodied robots that can squeeze into tight spaces.
So looking forward then, as entomology keeps expanding, what are the big questions, the challenges? You mentioned ethics earlier, maybe around insect farming.
That's definitely becoming a bigger conversation, especially as we consider insects more for food or for medical sourcing. Questions about insect sentience, welfare, those need careful thought.
And the environment. We hear a lot about insect decline.
Yes, and that is probably the most urgent crisis we face regarding insects. This rapid global decline in populations due to habitat loss, pesticides, climate change. It's not just sad, it's a massive red flag for the planet's health.
A bellwether.
Absolutely. It's a direct threat to our food security because of pollination and pest control and to the stability of entire ecosystems. So really, if we connect this to the bigger picture, entomology isn't just about studying little bugs. It's fundamentally about understanding our profound interdependence with them. It bridges this ancient practical knowledge with cutting-edge tech to tackle truly global challenges.
Right. It sounds like the future needs this really multifaceted approach. Sophisticated pest management, yes, but also bioengineering, ethical considerations, conservation. So maybe next time you swat a fly or admire a butterfly, take a second. Think about the incredible, often hidden ways these tiny creatures really shape our world. What stands out to you about their powerful kind of dual role?
Thanks for listening to the podcast on Dialogues in Science and Technology, PDST, and our deep dive into amazing world of insects. That's Field of Entomology. Stay curious and see you next time.